Hello everyone, welcome to the third lecture in the Pro Lego Pro Engineer Creative Elements Pro video tutorial series. So in our last lecture we went over the basics of modifying parts. So we modified the part we created in lecture 1 from a 1x1 plate to a 2x2 plate. So now, in this lecture we'll explore how to create parts that have radial symmetry. So this is a brief introduction. So a part that has radial symmetry means that if you slice it down the center, basically the center line, that the part is sort of revolved around. So, for instance, a shape like a sphere would have radial symmetry, or a shape like a cylinder, or a shape like a cone. Now, if we think about how we would create a part with radial symmetry, we could either, say in the case of a cylinder, just create a circle and extrude that, but then how would we create a shape like a sphere or a cone that have varying sort of thicknesses? So we'll go over that today. We'll start by creating a part. So we're going to create a Lego stud brick, which is sort of a rounded 1x1 Lego brick or Lego plate. So we'll call this, say, stud, and then 1x1. Click OK. So, as I said, we'll start out by creating our sketch. So we'll create the sketch, so it's on the front datum plane. So now, as I said before, when we create a shape that has radial symmetry, we're creating essentially the profile, so the cross-section of the part, and then revolving it around a center axis. So the first thing we'll do is create our center axis. So we'll click the center line tool. We'll place the center line on the vertical axis, vertical reference axis. Now we see we have our axis placed. We'll start drawing our part. So if we follow along, you can see we'll draw the sort of simple outline. Be careful not to involuntarily set any kind of length constraints, like that one. So the first thing we'll do is we'll delete these constraints here, because we don't really need these right now. So if we move everything around, we should have everything move independently of one another. So okay, so now, so we see we have our rough shape of what we're going to draw here. So we need to have this, basically, we'll set our dimensions as to how we want to dimension this for creating our shape, and we'll do so by creating what are called diametric dimensions. So we create a dimension between, say, this line and center line. So we have our sort of our arbitrary number here, which represents our radial dimension, meaning that this is, if we revolved this feature around the center axis, we would have this would define the radius of the part. So normally, if you're measuring with, say, a pair of calipers, you're normally measuring what the diameter is. So it would be kind of a lot of work for every diameter that you measure, divide by 2, especially if it's a sort of an odd number. So what we will do, instead of creating radial dimensions for each vertical line, we'll create a diametric dimension. We'll do so. We have the dimension tool set. We'll click vertical line, then click the center line, and then third click, we'll click the vertical line again, and then middle mouse button click. Try that again real quick. Okay, so you'll see we have our 2 dimensions that are set. We'll get rid of this, get rid of the first one. So now we have a diametric dimension which is mirrored across the center line. So therefore, this dimension is twice what this line length is. And that's of course useful for setting the actual diameter of the part, which if you're measuring a part that you're creating. If you're creating on a lathe or so, you want to be able to measure the part without actually having to take it off and try to measure where the center point is of where it's mounted. So we'll do that for each line that we come across here. Let's see. Now we do want to we want to set a constraint for basically a coincident constraint between this line here and this line here. The reason is that this surface defines the top of the part, and then this surface is where the peg, the stud, will insert into. And then we'll just go about defining a few more dimensions. These are just regular dimensions, so these aren't revolved, so they're not really radial. They just define what the height is. So we'll define a few more of these dimensions. Find this height. This height. Then we will set another equal constraint between this line and this line. So now, if we move one, let's see the other one will grow. Okay, so now we have most of our dimensions. We pretty much have all of our dimensions defined as to where we'll dimension from, but we have this sort of arbitrarily large part. Now this dimension here, we want this to be, about 0.8 centimeters, or 0.8065 centimeters. But if we set that, say 0.8065, you'll see all of a sudden our part kind of, no longer has the same shape we want it to have. Let's hit Control Z. So we can modify dimensions individually by using the Select tool of the mouse, or you can, if we highlight everything, we can go to the Modify tool. The Modify tool will let us, let's see here, we can change dimensions within this window. So we can use the wheel here to change the dimension and see dynamically what's going on. Or we can set the sensitivity to make this move either quicker or slower. But we can also scale the entire part. So you see, if we hit the Lock Scale button and move one dimension, the entire part scales for us. And of course, if we click on the different text boxes, we can see what dimension we're selecting. So we'll go with the largest dimension for the diameter of the part. So we type in 0.8065, hit Enter. You'll see our entire part will scale for us. So for now, we'll just click the check mark, and then zoom in here, Control D. Sometimes if it takes too long to zoom, you just hit Control D and then hit the sketch orientation button to reorient the sketch. But you'll see what we have now is our part that is the same shape that we had before, but it's more along the scale that we want to have. So now it's just a simple matter of setting the correct dimensions. So you see we already have our diameter dimension, our greatest diameter dimension set as 0.8065. Remember, our stud diameter is 0.478. So we set that. Let's see, our height of or depth of the stud, in this case, is 0.178. We hit that. You see our length here changes as well, the L1, L1. Let's see, this is 0.1 centimeters. And now the height of the plate is 0.3226 centimeters. And now all that's left is to dimension our inner sort of stud hole, which, if you remember, this was 0.388 centimeters, and the diameter of the hole is 0.2 0.58 centimeters. So you can see we have, we'll set the bottom dimension here, which is 0.74 centimeters. So our part now is in the shape of the profile of the cross section that we want. So as you can see, sometimes it's easier if we have parts that are circular, that are radially-symmetric, but have these sort of these cuts in them that we otherwise have to either create multiple circles or multiple extrusions of circles, and then create multiple extrusions of cuts to create. But we can also create that just by revolving this geometry here. Plus, as I said before, if we had a shape like a cone or a cylinder that we couldn't really create just using extrusions, then we have to find another way to actually create that. So using the tool that we will see, the revolved tool, you can see how easy it is to create, or how quickly we can create a shape like this, or a revolved shape like this, in as few steps as possible. So it appears that all of our dimensions are set. So we'll click the check mark, and then we'll click the revolve tool. So as you can see, if we click this line here, the line that was set at our baseline or our center line, see that we have roughly the shape. We have the shape of the part that we're trying to create. So it's this peg or this stud that is just on a circular brick or circular plate, and we see that's radially symmetric all throughout. Interestingly enough, we can also click on. So if we click on another surface or another line, let's see, we can create different parts or different shapes that all have the same cross section but are revolved around different lines. So as you can see, if we try to click on the center line or a line that's in the center of this part, it doesn't highlight, meaning that we can't revolve around that section because it's within the part boundaries. But if we go to one of the very outer lines, you see it turns blue. Click that, we have our revolution, or point that we can create a revolution around. Same to the bottom. So you can see from just one cross section like this, we can create, say, 4 different parts from that. So we'll just click the nut line on the center line. Also, we can see we can change how much of the revolution we want to go through. So we wanted to create a part that was only, say, 180 degrees revolution. You can do that as well, so it saves us from having to create a bunch of, extrude a bunch of circles and then cut out half of the circles sort of needlessly. We can revolve only halfway around, or if we want to revolve a little bit more, but not an entire part, so we can have sort of like a pie with a piece missing. But for our purposes, we'll just change this to 360, and then click check mark, and our part is done. So, of course, we'll save our part in our directory. Click OK. And that's it. So that's just an introduction to creating parts of radial symmetry. As you can see, we have our brick here. So that's it for this tutorial. Thanks for watching, and I'll see you guys later.